Hey students, Mr. Halpern here. So in this video, we're going to be doing balancing of redox reactions. You'll see here that there are 5 steps. We're going to go through each of these steps, and hopefully you will get to the point where you don't have to memorize each of these. It's pretty straightforward. The first is balancing the reaction in terms of like changing the coefficients, which is something that we've done before. Just to think about this one particularly as an example, I notice that there's one lead on the left and right, one chromium on the left and right. So I don't need to balance that. So I can move on to number 1 or number 2. The second one is writing the oxidation and reduction half reactions. Half reactions is something that we covered in a previous video, so if you're not sure how to write those, make sure you go back there. So we first have to identify what is being oxidized, what is being reduced. So in the case of this, you have lead. It is becoming more positive, so it's being oxidized. It's losing electrons. And then chromium is becoming less positive, so it's gaining electrons. Okay, so we're going to write an oxidation reaction, half reaction for lead. So Pb, now it's losing, which means that the electrons will be on the right-hand side. So lead becomes lead 2 plus, and in this case, it's going from a 0 charge, right, to a 2 plus in the oxidation number. So it's 2 electrons that it lost. And then conversely, this is, oh, I should label this too. This is the oxidation half reaction. Now, we're going to be doing the chromium, which is Cr3 plus. Now, it is being reduced. In other words, it's gaining electrons. That's going to be on the right, or the left-hand side rather. It's going from 3 plus to 2 plus. And so this is going to have be added 1 electron to get there. And then it's going to be chromium 2 plus. This is the reduction half reaction. Now, I'm going to move this down just so I can have more space. All right. So I've now written the 2 half reactions. The next step is, The next step is checking the electrons. If the number of electrons are different in the reaction, then multiply the entire reaction to make them balanced. And so let's take a look here. These are the 2 reactions. I see that 2 electrons were lost in lead, but I also see that chromium only added 1. So I have to change chromium's reaction, half reaction, to multiply by a number to get it up to 2. So how do we go from 1 to 2? I have to multiply by 2. So this whole reaction is going to be multiplied by 2. So this new reaction is going to be 2 Cr3 plus 2 electrons yields 2 Cr2 plus. Okay, and now what we're going to do is take the oxidation half reaction and our new upgraded reduction half reaction. And what we're going to do is we're going to add them together. As it says here, add all the substances on the left-hand side together and all the substances on the right-hand side together. So I'm going to write this as one giant thing, and this is going to be Pb up here plus 2Cr3 plus plus 2 electrons yields Pb2 plus 2 electrons plus 2 Cr2 plus. The last step is cancel out things that appear on both sides of the reaction. And I notice that I have 2 electrons on both sides. I can remove those. And the final answer is lead plus 2 Cr3 plus yields lead 2 plus 2 Cr2 plus. This is my balanced redox reaction. Now, next, I'm going to do one more problem. In this problem, you'll notice that the first step, which is to balance the equation, we haven't done that yet. I see 1 chlorine on the left, but 2 on the right. I see 1 fluorine and 2 fluorines and 1 fluorine. So we have to change this. I'm going to change the coefficient here. I'm going to change the coefficient here. What this is going to do is it's going to change the reduction and oxidation half reactions. Let's see. So again, for the oxidation, we'll use red. And oxidation is where we're losing electrons. So just to kind of fill this out, these are 0 charges because they're elements by themselves. And so we're going to say that in oxidation we have chlorine. Chlorine is being oxidized. And then with fluorine, you have going from 0 to -1. That means it's gaining electrons, so it's being reduced. All right, so the next step is now writing out the half reactions. So for oxidation, we see that we have Cl1 minus, and then this is going to Cl2 plus. So this is going to be showing electrons on the right-hand side. And how many? Oops, I missed my 2 there. How many? Well, if each chlorine, this is going to a 0 charge, by the way. So if 1 chlorine, right, was going to -1 to 0, that would be 1 electron, but there are 2 of them. And so we're going to have to do this for 2 electrons here. Okay? To kind of think of this like this, 2 is impacting the total number of negative charges. This would be 2 negative, right? So in that case, going from -2 to 0, you'd have to have lost 2 electrons. And this is called the oxidation half reaction. Now we're going over to reduction. The reduction is F2, and again, let's take a look. It's going from 0 to -2 because that coefficient right there is going to be impacting it. So that means I have to add 2 electrons. And so now this becomes 2F -1. Now, the nice part about this is that the next step is really easy. Both of them have 2 electrons. So I don't need to multiply the whole reaction of either of these by a number, by a multiple. This is, by the way, the reduction half reaction. Okay, so in that case, we could just add these up. And I can already see that my electrons are going to cancel out because there's 2 on the left and 2 on the right. So I'm not going to write them out in the final product here. 2Cl1 minus plus F2 yields Cl2 plus 2F1 minus. And this is my final balanced redox reaction. Take care.